Hey, what's up, guys? This is the heat of fusion of ice lab. So in this lab, we are going to try to figure out how much energy it takes to change ice into water. So how much energy it takes to melt ice. So the way we're going to do that, we're going to have some hot water. We're going to put that hot water into our coffee cup calorimeter, an insulated container, so that no energy or very little energy is getting out from the surroundings or in from the surroundings. And we're going to measure how much the temperature of the hot water goes down. And you can use the equation Q is equal to delta T times mass times specific heat for this water. And however much energy this hot water lost is how much heat was gained by this ice and how much was required to melt this ice. All right, so I got the calorimeter on here and it's zeroed. So we've got an empty calorimeter and our balance says that the mass is 0. And then I've got some warm water. It's not boiling, but it's warm. It doesn't matter exactly how much I put in, but I'll put in around 100 milliliters of water, maybe a little more. And so we got a mass of 101.6 grams. So 101.6 is the mass of our hot water. And the temperature of our hot water to start out with, we just wait till this reaches equilibrium. Looks like we're at 84.4. So 84.4 degrees on our initial temperature of our warm water. So now what I'm going to do, you know the mass of the water, you know the temperature of the water. Now I'm going to start adding ice cubes. So I'll start adding ice cubes. And as we do that, the ice cubes are going to melt. And as the ice cubes melt, energy is required for that process to take place. And that energy is being supplied by the hot water. So I'm just going to keep adding ice cubes until our temperature gets down close to 0 degrees and until the ice cubes stop melting. Okay, so we're at 23 degrees. Temperature's gone down a lot. We've melted a lot of ice cubes. And our temperature's continuing to decrease. We're at about 12 degrees. I've got a little bit of ice still left in here, so I'm going to keep stirring it and waiting for it to melt. And we want to get this as close to 0 as possible because then that makes the calculations easier. Then basically, however much the temperature of the hot water has changed, you'll take that temperature change times the mass of the hot water, and then times the specific heat of water, which is 4.18 joules per gram degree Celsius. When you multiply all that together, you'll figure out how much energy that hot water lost, and that's going to be equal to the amount of energy gained by the ice cubes. And that was required to melt the ice cubes. All right, so we're getting pretty close. We'll add about one more ice cube here. Most of the ice that I've added has melted. We want to get it till we're close to 0 degrees and until the ice stops melting. And then if we have a little bit of ice that doesn't melt, I can always pull that out. I've got like just one little chip of ice that hasn't melted yet, so I'm going to pull that out. Got a couple little pieces of ice that didn't melt, so I'm going to pull those out, put those back over there. And now we're very close to 0 degrees, close enough to 0 degrees, I think. And so now we can figure out how much energy was lost by the hot water. And to do that, you're just going to take the temperature change of the hot water. So that started at, was it 84 degrees Celsius? And it went down to 0 degrees Celsius. And so, and you know the mass of the hot water. So you'll figure out how much energy was lost by that hot water. And all that water was gained by the ice. So you'll know how much energy was gained by the ice. And then our final mass now is 208.9, 208.9. So you can subtract to figure out how many grams of ice actually went in there and melted. And you're going to convert that to moles so that you can figure out how many kilojoules of energy was absorbed by each mole of ice. All right, so I think that's all the data you need